To prepare A. Mixture. B. A compound using iron fillings and sulfur powder, and distinguish between these on the basis of 1. Appearance, that is, homogeneity and heterogeneity. 2. Behavior towards a magnet. 3. Behavior towards carbon disulfide. 4. Effect of heat. Apparatus required. Hard glass test tube. Test tube holder. Pestle and mortar. 2 watch glasses. Hand lens. Magnet. Rack full of clean test tubes. Bunsen burner. Chemicals required. Iron fillings. Sulfur. Carbon disulfide. Procedure. A. Preparation of mixture of iron and sulfur. Take 7 grams of iron filings and 4 grams of sulfur and put them in pestle and mortar. Grind the constituents thoroughly. The product so obtained is a mixture of iron and sulfur. Divide this mixture into 2 halves and place them into the watch glasses. B. Preparation of the compound of iron and sulfur, iron sulfide. Transfer half of the mixture from one of the watch glasses to a hard glass test tube. Hold the test tube in the test tube holder. Heat the mixture strongly on a Bunsen burner till its contents start glowing with a reddish glow. Stop heating. It is observed that the test tube will continue glowing for some time because iron reacts with sulfur to form its compound iron sulfide with the release of heat energy. When the contents of the test tube cool, break the tube and gently remove the pieces of broken glass. Transfer the compound formed in the pestle and mortar and grind well. Now, transfer the powdered compound into the watch glass. Now, perform the experiments. 1. Action with magnet. Roll bar magnet in the mixture as well its compound. Observations. Iron particles cling to the magnet in case of mixture, but not its compounds. Inference. Constituents of mixture can be separated by physical means, but not that of a compound. 2. Observation under magnifying glass. Observe the mixture as well as its compound under magnifying glass by spreading them thinly on a paper. Observations. In case of mixture, the grey particles of iron can be seen clearly in yellow particles of sulfur, and they are not uniform throughout. In case of the compound, uniformly grey particles are seen. Inference. Mixtures are heterogeneous in nature, but the compounds are homogeneous in nature. 3. Action with carbon disulfide. Place a small amount of the mixture and the compound in separate hard glass test tubes and add 5 cc of carbon disulfide. Shake well. Observations. In case of mixture, the yellow particles of sulfur dissolve and grey particles of iron settle. In case of compound, nothing dissolves. Inference. Constituents of the mixture can be separated by physical means, but not the compound. 4. Action with heat. Place a small amount of mixture and the compound in separate hard glass test tubes and then heat them strongly in the Bunsen flame. Observations. In case of mixture, sulfur melts and then thickens. In a few moments, the test tube starts glowing with a reddish glow which continues even when test tube is taken out of Bunsen flame. Finally, it forms a grey solid mass. In case of compound, no visible change takes place and no gas is evolved. Inference. The mixture of iron and sulfur on heating reacts chemically to form the compound iron sulfide. The compound iron sulfide does not undergo any chemical reaction on heating.